Welcome to Complexity Made Simple. My name is Paul Allen, and the subject of today's video newsletter, well, we're going to dip into a lean subject today rather than a Six Sigma subject, and we're going to take a look at the use of computer systems versus the use of pull in your company. And this has been triggered really by the fact that I'm traveling the country, meeting lots of clients, going in to talk to them about problems that they have, and quite a number of them, when we talk about stock availability, stocking out, having to change the production plan because they've run out of something, and they're switching production on the head of a pin almost. When I say, well, shall we do some work to correct that? They always say, "Oh no, it's okay. We're buying a new computer system. We're implementing SAP, or we're implementing Oracle or something like that, and we're going to solve the problem with a whacking great big computer system for day-to-day operations." And well, I don't think it's going to work, to be quite honest. And what I'm going to talk to you about today is why your computer system never works, and why you're constantly wrestling it, why you're constantly using offline Excel spreadsheets, and it will never get any better. It is unlikely to get any better if you continue to use a computer system for day-to-day planning and activity, day-to-day planning of the production process, day-to-day planning of your purchasing decisions. So let's take a look at this. We're going to go computer systems versus pull. And by the way, before we get into this, if any of you are watching this and you think you have the perfect computer system and it's working perfectly well with no effort whatsoever, please send me some comments. I would love to talk to you. I'd love to find out how you do this, because for most of you, what have you got? You've got off-site warehousing, haven't you? Be honest. You've got off-site warehousing because you've got so much material, you've got nowhere to put it. And yet, even though you've got off-site warehousing, you keep running out of stuff. How is that possible? Well, let me show you. We're going to talk about why computer systems can never work. So at the heart of this problem, the heart of your computer system, why is it never going to be accurate? Why is it always going to give you problems? Why are you always going to be fighting it? Now, this is at the heart of the problem. Inside the computer is something called static data. Information that you put in once. You put it at the beginning when you set up the bills of materials, when you set up the routes and things like that. And the sorts of information that you put into your static data are, you might put economic batch sizes. You might put minimum order quantity, lead time, although sometimes lead time is a calculation of some of this stuff. What else would be in there? Well, obviously the bill of material information would be in there. You might put defect rate, attrition rate in there, although I have to say what lots of people do here is they keep that at zero because they can't cope if they put a defect rate in. What else do they put in? Setup times. They might put setup times in there. And of course what this allows the computer to model reality, because that's what it's trying to do. So as you set up a new product, you try to set static data up that tries to model reality. But of course, once it goes in the computer, you forget all about it. It's just sitting in there, and the computer just spits out numbers, and the static data is completely forgotten about. And it's completely forgotten about by the people who now are trying to run reality. They're not trying to model it, they're trying to plan it in reality. They're trying to plan a batch size, a run rate, etc. Or I suppose other things that might be in there, by the way. Cycle times. That would be another one that tends to you make a guess at the beginning, and once it's in there, you tend not to change it. But anyway, there's more static data. So once all this information's in, the people that lay their hands on the process for real, they forget all about this stuff. So the planner, he will plan batch sizes based on literally the situation at the time. So he will put all sorts of his skill into the plan, and he'll completely ignore the fact that there was a batch size in the computer that was recommended to him, because now he can see reality, and he's either saying I need to go for bigger batches or I need to go for smaller batches, and so he's changing all of this information, and you completely ignore all of this stuff. So the computer never reflects reality, so it's bound to be wrong. Now then, in order to try and get around this, what happens is the people that manage your systems try to take control. They try to put their skill in, and they try to fight the system. So let's talk about whether you can actually fight this. Can you defeat the computer? Well, once this information is in, if you don't change it, the computer will always defeat you. And let's just look at one instance, which is the defect rate. So you could put a defect rate in the computer. Most people don't, and the reason they don't is because of the backflush. So what would happen if you put a defect rate of, let's say, 2.5%? What the backflush would do, if you order 100, the backflush would backflush 102.5 of your parts. So of course people can't deal with that fractional calculation, and they consider this illogical, and so they won't put a defect rate in. Okay, but that's okay, because the purchasing officer will deal with that, and they'll just override it. Okay, so purchasing officer overrides it. So look, let's say into the computer we get a demand for 100 pieces of something. So there's the original demand. What this generates into is a purchase order, a purchase request. Computer can see this. What does it want the purchasing officer to buy? Well, it wants the purchasing officer to buy 100 components. And it doesn't matter what the component is, but it's a single component, and the purchasing officer is looking at this requirement for 100 pieces. But they know they've got an attrition rate, they've got a defect rate that the computer can't see. So what do? Well, they override the request, so they don't order 100. What they do is they put some just in case on top, and they order 110, because the 2.5% is an average, and sometimes the attrition rate is at 2.5%, but sometimes the attrition rate's a lot higher, sometimes it's a lot lower. The purchasing officer wants to be safe, so what does he do? Sticks a bit of safety on the top. Now what does the computer do when it sees this? Because the computer can see this. So it says, well, I had demand for 100, but I've now got an order for 110. So it now thinks I've got 10 spare. All right, so now another demand. Customer comes back to you and orders another 100. But what does the computer do now? Well, when it sends the demand through to the purchasing officer, it says, well, I had demand for 100. I would have told you to order 100, but you've already got 10 spare. So what I'll tell you to do is order 90. Now, of course, the purchasing officer's not going to order 90 because he knows he's still got this problem. So what does he do? He puts a bit on top, doesn't he? So he says, no, I'll order some more again. Actually, now what he's doing, he's only ordering the right amount, but he orders 10 more again. So now what does the computer start to do? Well, the computer starts to go, yeah, I can still see plus 10. In fact, there's 10 plus here, so now I got 10 plus 10. So the next time now, you get demand for 100. Now what does the computer say? Give me 80. Purchasing officer says, no, I'm going to order 90. So now look, there's 3 lots of 10. So now computer says, anyhow, I can see I've got 32 many. Now eventually what's the computer going to do? Well, eventually the computer's going to say, I've got demand for 100, but you know what? I don't need to order anymore. I've got this stuff. All right, so the purchasing officer is constantly fighting, but the computer fights back because it takes the static data, like your defect rate, and it says, no, I'm okay. The computer always fights back. Now, of course, this is one error here. What other kinds of errors can you get? Well, ask yourself this question. When you run the computer, for those of you that run SAP and Oracle, do you ever get negative numbers? Now, negative numbers are clearly an error, we know that, so we try to get rid of them. But you see, negative numbers are the opposite side of positive numbers somewhere else. So you could just go in and miscellaneously write the negative up. But what that does, it leaves a positive of some other component sitting in the system. Now, where does this tend to come from? This tends to come from your bill of material errors. So if you don't have the bill of material correct, and then you manually override it, when the backflush goes off, the backflush will flush the wrong components. It'll flush a component that manually someone's overridden when they picked it and they didn't actually issue it to production. And what that does, of course, it drives that particular stock negative. If you just go in and write that up, that is a very dangerous approach to take. So what will happen? Well, of course, you've backflushed the wrong component. So you have 100 negative of the wrong component, but you have 100 positive of the right component. And it's the computer now is telling you you have 100. You don't have them. You use them making this order. So when you have negative numbers, you have to be super careful how you deal with them. Now, people aren't. They just write these up to 0. The minute they write these up to 0, they create positive errors. Positive errors are very dangerous because positive errors mean eventually you'll order no parts, or you'll ask for no parts to be manufactured. And you can see, so this is bill of material errors. This is defect rate errors. But of course your setup times could be wrong, your batch sizes could be wrong, all sorts of bits of information can be wrong that just make the computer completely misbehave. You try to override it, the computer uses the static data again and puts you back where you started from. You cannot fight the computer. Static data will kill you, and it always kills every system. That's why you're all using offline Excel spreadsheets to try and deal with this nonsense. Now, what does this do? Well, the pull system, see, there's a difference here. What this computer's doing is it's working in the theoretical. It's saying, well, theoretically, life should be like this. And if you try and move away from the theoretical world that the computer lives in, it'll pull you back to theory. This thing, on the other hand, always activates in the practical. So, of course, what are we going to have? Let me just clear a bit of space here on the board. What are we going to have with a pull system? Well, with a pull system, of course, you're literally going to have stock sitting either in production or in the warehouse. So you're going to have a stock level. At some point, you're going to put a make signal or a purchasing signal. Now, obviously, all of this calculation, how much stock do you have, where do you put the signal, it's based on theory. So yes, it's based on theoretical demand. Yeah, and lead times, and we'll also say defect rate. Same as the information over here. So let's say the theoretical demand, as we mentioned earlier, the theoretical demand was for 100. So we designed our pull system based on that theoretical demand for 100 every, let's say demand every week, 100 a week, and we didn't put a defect rate in the same way that we haven't over here. That was the theoretical calculation we used in order to design the system. But pull systems work in the real world. They don't work in theory. So here's what happens. We designed the system to work like that. But let's say now the customer chooses to pull 110 a week. So some of the numbers change. Or we have, let's have a look, plus we'll say there's a 5% defect rate that we didn't design in the same way that we had a defect rate over here. What will the pull system do? Well, all that will happen is the pull system will hit the trigger faster. And it'll just constantly keep pulling parts in at the right rate. The other thing about it, of course, is any problem that you get is always in the shadow of a satisfied customer. Because when the customer comes for 100, you've got 100 to use because you've always got stock. You're always buying stock, and therefore you are always in the shadow of a satisfied customer. So if you get a problem, normally it's a problem that exists, but it's an internal problem, not an external problem of your on-time delivery being smashed to pieces. So this thing now, even though these numbers are wrong, so we had these theoretical numbers that we designed the system to, this system will just cycle a little bit quicker than we originally intended, but it's perfectly happy. In fact, I recently did some work with a client where the demand for some parts was increased by 3 times. Yeah, so this thing would have gone up to 300. And we did a little simulation of a pull system. Had they used a pull system, would it have coped? So we had it set at this level, but demand went up to this level. And you know what? The pull system would have just kept functioning. Now this could have been a pull system that made your production make, so it could be a make signal. This could be a buy signal. It really doesn't matter. It's just a signal to tell you what to do next. But it works in reality. If these numbers change, the pull system starts to work faster. Now don't get me wrong. Normally, if this thing goes too wild, eventually you'll strip the pull system out and you'll hit the bottom of the safety stock, and you'll know that something is wrong eventually. But you know what kind of problem is that? The problem is you're selling way too much. You know, that would be a disastrous situation. But you'd kind of know that, and you'd be reviewing all your pull systems because demand has gone crazy. So here's the difference: computer systems versus pull systems. Let's just take a look at a slide and let's just summarize some of the issues with one versus the other. So if we look here, look, I've got a slide: computer versus min-max or pull system. And what do you see? Well, number one, the computer costs £1 million. You are about to do a test, a trial. You are about to do an experiment, and you're about to do it with a piece of software that costs you £1 million and probably is going to take you a team of 15 people to try and implement it correctly. If I use a min-max system, what have I often got? I've often got a piece of card or a piece of sticky tape sitting on a shelf. It costs 20 pence. Which one would you prefer to experiment with? Yeah, so £1 million or the 20 pence pull system. What else have we got here? Well, Because of all this static data, problem solving is almost impossible. You need a genius. If you stock out of something with all of this data and the way that it all interacts, you literally need a system genius to figure it out. With min-max, problem solving is very easy. Either the demand has gone up and you've got no safety stock, or you didn't put the safety stock in the right place in the first place. So maybe your rules for calculating the limits are not appropriate. But because there's only a few things to consider in a pull system, it's very easy to problem solve. What else? Well, the computer works on theory. It says there's a theoretical way the world works, and it forces you to try and follow its theory. Whereas the pull system, the min-max system, that will work on the practical. And even though theoretically you'll get some of the numbers wrong when you've done the calc, actually the pull system has the resilience to cope with that. It changes to suit the world. It doesn't try to make the world fixed to it. And that's a very, very big difference. So there are some of the real big differences between your computer and pull systems. And of course, I'll ask the question again: do you have off-site warehouses? Do you run out of parts? Do you constantly have to review your purchasing decisions? So you placed orders yesterday, and now it seems to be telling you to pull those orders forward. So you're constantly reworking. You're constantly reworking the plan. You're constantly reworking your purchasing decisions. That would be a sign that your computer system is working in the theory. It's not working in the real world. So if you're really lean, you're doing this. If you think you can be lean with a computer system, you are badly, badly misguided. And of course, this, it offers a world of money-making possibilities, does lean. A world of money-making possibilities. Why don't you switch the computer off, take all the IT people and turn them into pull system designers, turn them into process improvement experts, because you've got an office full of IT staff as well, trying to sort this out and modify it and upgrade it and all sorts of things. The costs associated with this are huge. Go lean, put pull in, use bits of sticky tape and cards, and make more money. Now, just a little addition to that video about computers versus pull, because people are going to say, yes, but I have to have a computer for forecasting and for accounting and for all of that kind of, and stock control and all of that kind of good stuff. So if I'm not going to use the computer to activate the day-to-day plan, what am I going to use the computer for? Well, here's what you should use it for. You use it for your long-term forecasts. So the example here would be McDonald's making a burger. Yeah, so in the store, they're going to make a burger. In the store, are they going to use a computer to predict when the customer comes through the door? Now what they do is they use a simple pull system, and they make a small amount of stock, which means that they can service the customer really quickly for standard product, by the way. That's important. So what we're talking about is you put pull in for standard product. So they put a pull system in. But of course, one of the things they've got to do is they've got to tell the farming world how much beef they need for the next year. Well, that's a long-term forecast. Now that's a great use for your computer. So imagine you're making something, you're making a complex assembly. It's got lots of different parts in. Some of the parts are duplicated, triplicated, etc. Bill of materials really complicated. You've got different types of models where some parts are different to the others. How do you tell the supply chain what you need? Well, of course, this is great. You can put approximate numbers in, and you can say to the supply chain, I think we're going to be using 10,000 a month of this. You know, I think we're going to need 10,000 cows a month for the beef for the UK, because you can't put cows on a pull system. Yeah, you have to plan that ahead. And that is what you use your computer for. You tell your supply chain, come on guys, get ready. There's 10,000 a month coming down the line. There's 3,000 a month coming down the line. And that's the generality that you use the computer for. So your supply chain can man up. They can source materials. They can tell their supply chain, this is the amount of raw material I need to make these pieces. That's what you're using your computer for. Now, of course, if you want to use it for stock control and you want to use it for accounts, how do you deal with that? Because when goods arrive on a pull system, how do we book them in? How do we pay the supplier, etc.? Well, here's what you do. You take an order for 1 million. So a purchase order, you put a PO for 1 million on the computer and you push the date out to 2080 so that it doesn't interfere with your computer. So if you want to run simulations and things on forecasts and things like that, it won't interfere with it. Then every time this item arrives on a pull system, so pull, it pulls a single item in, there's a standard purchase order waiting for it, and all you do is you say, oh, 100 arrived of this item, and you just book them in on this standard purchase order. So purchasing don't have to keep raising purchase orders. You don't have to keep doing that. You've just got the system set up with all these big blanket orders. You book them in, which creates stock control. And of course it creates accounts, creates payment systems, you pay the invoices, everything works. That is what you do, that's what you do with your computer system. But if you try to predict when the burgers are needed on the exact minute, think about it logically. That is never going to work, and quite rightly, McDonald's don't use a computer to predict that. Why are you using a computer to predict that? It makes no sense. Use a pull system to activate the plan. Use the computer to make a big long-term plan. Everything will work sweet to sweet can be, and you will make more money. Use pull and make money.